Alright. So if we look at what we have up here on the board, all right, we produce what? Back to biology class. We produce ammonia, right? Now, if you should see ammonia on the test, let's see what is it? NH6. All right, so ammonia from what? What is it made from? All right, so nitrogen plus hydrogen. What do we know about those two elements? They're one. They're one of the 7 diatomics. So from there, is it balanced? So we're going to put a 2 here to make ammonia or make the nitrogen 2. We made 6 hydrogens, so 3 there, right? So if we cruise back, a minute ago we said we had the same temperature and pressure. So same is not standard. Can't plug into PV equals nRT. Can't use any of the other formulas like P1 V1 over T1. So all that leaves us with is a T-chart. So given that, looking here, we have 17.5 milliliters of ammonia. So 17.5 milliliters NH3, milliliters NH3. Now, a couple people first period said, don't we have to change it to liters? The answer is no. You can do it in milliliters or liters. Either one is fine. It's your pick which unit you want to use. That's why it's lazy. When you look at the question, did it say to do it in what volume of liters? No, it just said milliliters. So, volume, I'm going to put M on the top. Liters, milliliters. I'm going to go, what compound did they ask me for? They asked me for the volume of hydrogen. So I'm going to put hydrogen on the top line. This is the same thing as what we used to write with mole over mole to change compounds. Where did our numbers come from in moles over moles? Coefficient. So what's in front of ammonia? What's in front of hydrogen? Okay. So somebody tell me what we get when we multiply and divide. 26.25 milliliters of hydrogen. All right. As long as you have the milliliters, I would not take off if you didn't write the hydrogen. Question. Everybody good? All right. So the second one. Now, if you're using an oxidation sheet to do this, you get your blue table reference sheet. That's it in a periodic table. That's all you will get on test day. So when you have to write potassium chlorate, okay, decompose it. Look at page 7. Okay, on page 7, you have. That doesn't work so well. Try that again. Let's go back to here. Now let's do that. Left way. All right, so potassium is K. What group is potassium in on the periodic table? What's its oxidation number? All right, on page 7, for those polyatomic ions, what is chlorate polyatomic ion? ClO3 with a -1 oxidation number, right? So, what happens to those ones? They cancel out. Now, if you remember what it decomposes into, you have a better memory than most students, okay? Some people do, and that is great. A lot of people just don't. So, if you look on your reference table on page 6 and flip back over to decomposition, this matches MClO3 breaks apart into MCl plus O2. So, what goes where the M is? Right? With Cl and then plus O2. Now, KCl is a compound. We have to look up the what? All right, so K has what in front of it? And Cl has a -1. They cancel out. Is it balanced? Okay, so if we look at our equation, what elements don't balance? The O. So O has 3 and O has 2. So what am I going to do if I got 3 and a 2? And put a sub. Given that, I have how many K's? And I'm going to put what here? So 2Cl, 2Cl, I'm good to go. All right, so from there, back to the number. What do I have here? All right, so 25.3 liters of oxygen. Liters of oxygen, 2 liters. All right, what did I ask me for this time? Okay, that's KClO3. All right, liters to liters. What do I have? Okay, so if I look back here, 2, whoops, 2 and 3. So, whoops, I'm waiting. All right, and I'll just put it off on mine. 2 and 3. Somebody tell me what they get. 16.8. And then I have liters of KClO3. Question about how to do that. Question about how to do it. Anybody? Are we okay with it? Can we look at homework? See what kind of questions you have if you do it? All right. Now, this should have been a really easy one to do because the equations are written and balanced for you. They are not written and balanced for you on the test. There are 10 multiple choice, and there are 11 words. Yeah, there are 3 stoichiometry problems. 1, I've written the equation, I didn't balance, but I wrote it. And 2, you have to write. 1 of them is volume, and 2 of them are like we're learning today. And again, because everything takes so long, I just can't get crazy. You guys tend to work faster, but in first period, I have 4 who always go to the bell, and 3 who I'm literally shoving out the door who are usually still with me during grab and go. All right, and number 1, you should have 15 liters. H2, okay. 2, 10 liters of NH3. 3, 12 liters of CO2. 4, 15 milliliters of oxygen. 5, there's 2 answers. You had to do both here. So 5 is 75 liters of CO2 and 37.5 liters of oxygen. Anybody need me to do anything in the homework? Okay, was anybody absent? I need to give the homework to Renee and John. All right. Of what? Sure. All right, so if I give you something like magnesium chloride on the test, you have to write the formula. All right, magnesium is Mg. All right, it's in group 2, so it's +2. Chloride is over here, so it's -1. 1 comes down, 2 comes down, and you get MgCl6. All right. The groups are in. Now, if I give you something in the transition elements, there's only 2 you're supposed to know from the transition elements. Zinc is +2. and silver's +1.
Oh, really?
Okay, so anybody who's not one of those, what do I have to do? I have to give you the Roman numerals, so I'd have to say like manganese, let's say 7, and let's say I say, let me have your blue table, so I gotta make sure I limit myself to what's on the column now. Okay, let's say I do that. Manganese 7 for manganese. Okay, you would be expected to write that based on what's on your blue sheet. All right, manganese is what symbol? Mn. I'm telling you to use what? +7. And permanganate is not on the periodic table. Where's permanganate? It's at the end, so it's a what? Oh. It's the polyatomic ion. What is permanganate? MnO4. Its oxidation number is what? 1 comes down, 7 comes down, and you get MnO4 with a 7. Like that. Question. That's like old system with the prefixes you read on the test? Possibly. Like what if I said write or find the density and I gave you, let's say I said carbon tetrachloride. Okay? If I said carbon tetrachloride, how would you use anything that's an old system? That's right. So carbon has what prefix on it? Nothing, right? That means there's no prefix, so no subscript. And yeah. Sulfur oxide would be, guys, I think the one we did on the, I can't remember if it's sulfur trioxide or sulfur dioxide. So sulfur was sulfur with a prefix of 1, and then trioxide, that might have been the one we did that had a 3 on it because I had tri. Okay? Anybody else? Question or naming? Before we move on. No? Okay. Everybody feels better about that? Okay. All right, the last thing with the gas wall. Where are you going to? The thing. That's not that far away. You make it sound like you're going like we don't. I don't get that. Oh, no. I'm certain you're right. Whatever. 3 hours. Here. No, I think you're a lot. We're going to a college. I use the blow dryer. Other than that, yeah. You should do that one day. Just didn't see it. My hair was awful. I just don't want it to come out wet. Very nice. I'm still waiting on the really kinky hair though. That's what I need to see. Just 4 miles away from me. Oh, sorry about that. All right, so we're going to do volume mass stoichiometry. It is the last problem that we have to do in gas laws. And then we're moving on to some other topics that some of you will like and some of you will just hate. All right. Unfortunately, they're a big bulk of what you may very well see on the exam, or what people have told me for some exams. Even though I tell people you're not just coming up from the exam. All right. Now, in order to do these questions, volume, mass, stoichiometry require us, all right, so we must use either A, volume, or a mole ratio, okay? We must use either a volume or a mole ratio. Now, I am going to elect today to teach it using a volume ratio. But I'm going to point out where you can use a mole ratio, because some of you are naturally going to gravitate to a mole ratio, okay? And it's going to happen when I let you loose to practice on your own, okay? It happens in first period. A couple people say, well, is it okay if I did it this way? And the answer is yes, it is, okay? And given that you guys tend to want to take off and work on your own, and it's going to happen on Earth Day all its own. It's going to work that way. Okay, write it down while I'm down. Because I need it to look at the question for you. Yeah. In here? And on it. Oh. And for a 4th grade, I'd have to go with a 2 or 3. They stopped coming. Oh, they stopped coming. They were here. They quit work. They just stopped. All right. Has everyone finished writing? Thought up? 16. 16. You can't drop out before 16. Some. And we have some students who are here and are required to be here and just do nothing before they're 16. And that's another way you can wind up in that stuff, like using the department, which unfortunately happens in some. But that's the way it is. All right, so look at question 3 on your quiz paper. Okay? So question 3 and the question on the board are very, very similar. And people work the question on the board and question 3 almost the same way, and then lose a ton of points on the test because that question is very different from question number 3. Okay, question 3 on the quiz says find the mass of oxygen in STP. Find the mass of propane. When it combusts with oxygen with a volume of 5 liters of CO2 at sp2. What's the difference between the two? Mass and grams is the same word. So that one asks for mass, that one asks for grams. It's the same thing. Okay. Oh, this one says the word combust. That's one thing. Okay, that uses the word combust. All right, the next thing I want you to notice is the number of compounds. How many compounds does this have? How many does the question number 3 on the quiz have? 1. Okay, this has 2 compounds. It equals a balanced equation. All right, question 3 on the quiz only said oxygen. You only used oxygen. You didn't need anything other than oxygen. However, this one has 2 compounds, and you have to use a balanced equation. This one, excuse me, is a stoichiometry problem. Okay, do you see the difference? All right. Now, if this had been a question on a quiz or a test, I would have told you what propane was, and propane is C3H8. I would never expect you to know what propane is. That's just a typo on my part. I would not expect you to know that. So don't feel like you're supposed to know that compound. That's great if you did, but it's not one I would expect you to know. Now, from here, all right, let's write the equation. Propane is what? C3H8 plus, and we get what 2 products? H2ON, CO. Remember, if you forget that, you can look it up where? On your reference table. You can just look it up at the bottom of page 6. So there's how many C's? So I'm going to put 3 C's. How many H's? So I'm going to put 4 to make 8. And I have 3 plus 4 is 2 is 6. Plus 4 is 10. Everybody go, I got 10. I probably said it wrong, but that's 10. So how do I get 10 here? Put a 5. Everybody okay with our balance? Okay, so we have the equation. So setting up PV equals nRT. Now you can do this with big M. I don't do it with big M because where I'm going to use a 2-step conversion chart, if you mess up and do moles, you got to do grams to grams, which is a how many step chart? Grams to grams is how many steps? 4. And I already told you this wall's what? That's right. So I don't want to do a 4-step chart. I like a 2-step chart. So I'm doing PV equals nRT because I'm all about less steps. So can't keep this because I do too much work and exercise. So I just can't. I admit that over there. So my doctor that all the time. I doesn't find it amusing either. So when I have SPP, what do I know? Okay? And the temperatures, and we know R is. So we're good on all that. We just got to figure out this whole volume and mole stuff, right? So I have 5 liters. Now, don't write this part down. Okay? Stop writing. You can write, but I have an orange, and you're okay. Just don't write what I'm getting ready to write in red. Now, once I have that, people tend to jump ahead to PV equals nRT, and they tend to go, oh, 1, 5, moles, 0.0821, 173. Oh, moles, grams, find mass. And they've got it. Plugged into PD for 1RT. I got moles. I changed my moles to my grams. Got it. Home free. Now, what did I never use when I do that? That's propane right there. Mass of CO2 happens to be the same as propane. It's really convenient. What I never used. I never did anything with that balanced equation we wrote, did I? Well, I'm going to write on your paper. Look, you wrote a balanced equation and you didn't do anything with it. You worked it just like you worked question 3 on your quiz. You recognized I needed a balanced equation. You wrote a balanced equation, but you had no idea what to do with it. Okay? So, that's why I told you how to write that. You can do it 2 ways. Okay? I told you, since this is gas law stoichiometry, I was going to do this with the volume-volume ratio. Okay? Since this is volume is given, all right, I'm going to use a volume ratio first. Okay? Now, if I'm finding volume, I'm going to do a volume ratio when? Last. Okay? But since volume is given, I'm going to use the volume ratio first. Okay? So I'm just going to write this here. If I'm finding volume, we do the volume ratio last. But since the volume is given, we're going to do the volume ratio first. And the next problem, we're going to find the volume. So we're going to do the volume ratio when? Last. Okay, so it's going to depend on what's given as to when you do it. But in this case, it's first, so I'm going to do it first. So, what did they give me in the question? This is 5 liters of CO2. This is CO2. So I'm going to draw my chart, just like our homework. And I'm going to go 5 liters of CO2, and I'm going to change it to liters of how many grams of propane? So C3H. Okay, so C3H8 has what in front of it? 1. And CO2 has a what? Okay, if I remember from first period right, I think that's like 1.66. 1.66? Okay, 1.66 liters. Now, so instead of this, I now have 1.66 liters of propane. Now, I have the same problem you worked on question 3 on your quiz. Now it's PD equals nRT and solve. So pressure is what? Volume is, and we don't know, R is 0.0821, and temperature is, all right, so we're dividing by 0.074. I only remember that one because we argued about it. Oh, and they told me I punched them a couple times. Because I didn't write the math on the board. A couple people punched me wrong. Huh? Yes. All right, so the last step, they wanted grams. So what do? Yep. So 0.074 mole, gram, 1, and then C3H8. We're going to put 44 there because that's the mass of propane. And I don't remember what we got. 0.222. So it's 0.22? 3.2. Okay. Again, as long as you're close, I'm not going to mark more. That'd be fine. All right, we good? Done? Yes, I'm going to do one that's the opposite. All right. Write that one down. Notice I wrote imbalanced equations for you. And then we're going to work this one together. I'm going to go ahead using one by itself. And then we're going to practice. Yeah.
Miss Wall?
Yes, ma'am.
Hi, pardon the interruption. Do you have Passion Phillips?
I do.
Please send her to the Thank you.
All right, y'all got it written down? Yes, no, maybe? Yeah. Okay. Thank you both there. All right, so if we look at what we have. All right, so if we look at what we have here, all right, what's different about this question and the last? There's more numbers. Yes. All right, we're finding volume. All right, this time you have mass and you're looking for volume. There it is. All right. All right, we'll change the color here. All right, so we have 745 torr, which is a pressure, right? And we have 35 Celsius, which is the temperature, and we know R. And I just wrote those down because honestly, at this point, if we don't know that, what I'm working on in this question is kind of a waste of our time. So is everybody okay with those? Okay. So the 875 grams goes where? It goes with that. And so we're looking for volume. Now, the 875 grams is grams of what? Which one of those compounds is tungsten oxide? WO3. Okay? So, if it's WO3, I'm going to put grams of WO3 here and moles on the top. 1, and then WO3's mass is 236. Y'all trust me with that, or do I need to show you where it came from? Okay. Now, when I find, there it is. When I find my mole, okay, 875 divide 232, I get 3.77 moles of WO3. Now, I told you that I was going to do the volume-volume ratio, right? So, I'm going to do my volume-volume ratio like I said here. If I'm not given volume, if I'm finding volume, I do it at the last, at the end, right? But some of you are very bright, and you're going to figure out, oh, I got moles. You might have said, oh, you could have just decided to go ahead and do your mole-to-mole ratio now. Completely cool if you decide you want to do it that way. I'm not going to choose to do it that way because I'm pushing volume-volume ratios because it's a new skill we're learning, okay? But you can if you want. All right, so torque, that should be about 0.98 ATM. 35, 273, 308. And that should take care of it. Okay? So, plugging in the PV equals nRT. Our pressure is 0.98. Our V we don't know. Moles are 3.77. Hey, Blackwell. I don't know yet. Anything runs through the double. I just tell you. That's why I emailed you and put it in the form.
No, you don't need to.
Okay, okay.
I've already put the schedule together.
I know. I just read the email. And you just have to pass through. But I don't know to tell you. And I just supposed to let me know. Why don't I just say you Wednesday? And just make that decision. Just say I'm going to do 13 wrong day, wrong time, just a royally message you get. Because you know you're not doing anything the rest of the week, and I'm just going to test myself the wrong day, the wrong period. Just you can't do anything to test. Will that work for you?
Just email me what you need.
Okay. Oh, you have to touch God. That's how they're answering you. Everybody tell me that. Oh, you go. Oh, I mean, so I don't know. I want to check I'll be back. Okay. I know.
Hey, Emery passed out.
Oh, good. Did the little quick one there go?
It did. It's really good.
The little special was amazing.
This, I'm going to go back. Okay, the whole thing. Just a little, you know what, just a little. She goes, she has to get there. She got to get
Let's say off the first one. Oh, and in case y'all didn't get that, in case I have to be out, that only affected the first part of the day. That didn't affect y'all either. It's sort of like force for that first, second, third bit. Oh, that thing I was just talking to Black Hole about with third period with the whole benchmark thing. Won't affect y'all. Okay, so I had to move my third period benchmark because I might have to be out Wednesday, first, second, and possibly third period, but it won't affect fourth. It won't affect fourth. I got 97.2. You get that? You already answered? Okay. That sounds like what I remember, Andy. Okay, 97.2 liters of what? Say what? You called it two scan? That's called tungsten. All right. So, because this is what we were using, WO3, this is WO3. That's tungsten. Okay? Huh? I don't know. I'm guessing Latin off the top of my head. Okay? But the tungsten is the element, you know, the old light bulbs, the incandescent light bulbs that we used to use before we moved to compact fluorescence. Those were the metal filaments we used to break that were the light bulbs blowing up and we had to throw out and get new light bulbs. That was the metal filament that broke. That was tungsten. Yeah, you can still get them because they made so many of them. They're sitting in warehouses. And so as they set, we're not making anymore. So as we sell them off, they can't be replaced. Okay? Yeah, but they're still out there and available. And the reason, of course, that we've stopped making them is because they're so not energy efficient. Most of the energy is lost to heat. All right, so liters of WO3 is being changed into liters of what? Hydrogen. Okay, so from liters to liters, what do we do? Okay, so what's in front of hydrogen? And in front of WO3? Very good, and what do we get? 291 liters of H2. You got it? Think you can try one on your own? All right, so let me give you one to try. All right, here we go. Oh my God. All right, y'all try that. Don't put the thing up there. It's not bad. I wrote it, but it's not bad. Bill? Yeah, the top half, so the top half is what you want to do. Tell me what it is enough to burn over. How much? No. That doesn't mean it's wrong though. You got what? 60 grains of velvet. That could be wrong too. What was the answer? 538. You got what? I've got 543. So 538, I'd probably take it. Probably a year rounding. I don't know unless you got a decimal place off. Because you've got what? 65 or something? It could be a decimal. You put in like 0.821 instead of 0.0821. Yeah. All right, where are we at? All right, is everybody okay with what I put on the board so far? I changed P, I changed moles, I changed temperature. So is everybody okay with that so far? Huh? Oh, and then ATM, thank you, because I changed that. All right, so is everybody good with that so far? All right, so from there, you could have chosen to go ahead and do your moles to moles if you wanted to, and go ahead and do that. If you wanted to go ahead and do your moles to moles, that's where you would do it. Okay, if that floats your boat. Or you could choose to go ahead and say PV equals nRT at this point, and plug in your 0.247. B we don't know, 5.45, 0.0821, and 300. Because you could go ahead and get your change of the compounds done there. And then you wouldn't have to do volume again. It doesn't matter where you go ahead and change the compound, you could choose to do it in either place. Wrong place. I get 543 liters of carbon. Now, if I had done the purple, I'd be finished. But since I did not, and I used the green, all right, I have to go. A little different. I have to go liters of speed to liters of CO2 and do my 2 to get 543 liters of CO2. Now, if I had already done this in purple, I would be done right there because I would have already done that step. And since I hadn't, I have to do the green. Okay, but you can do it either way. You choose. Some people like the mole. Some people prefer the volume. But you can choose at this point which one you like. Question. Right. Depends on how you round. That's why I said if you'll show your work, it's all about the rounding. It could be the 0.247, 0.24. That'll do it. Huh? Oh, it is CO. I wasn't paying attention. I never looked at the reaction. I should. Be the teacher and all. All right, question. All right, can we look at some more practice on this? Okay. Get rid of that because I am done teaching.